Hello friends, welcome to C# Intermediate to Advanced tutorial. In the last sub-series, we talked about C# reflection and we retrieved assembly as well as type information. So in this sub-series, we will retrieve the method information, and at the same time we will make a call to method at runtime just by knowing the assembly output. Assembly output can be DLL or it can be a exe. We can load the assembly, then we can access the publicly exposed functionality through reflection. So in this video, we are going to create a DLL project with some test methods. So what we will do, the DLL project will expose a class, and the class will have a constructor and some methods. And in the next coming videos, 2, 3, 4, we will make a call to those methods. That means we need to create a object, and if we are going to call a member method, then we should create the instance. And if it is a static method, here we will look at a static method. Creating the instance will not be required, but you can still make a call to the method. Alright, so when we go to each part, we will get more detail about it. Now first we will create the DLL project and we will expose some sample methods. So that will be useful for next 3 videos. So here we are using system.diagnostics namespace. Why? Because in this example we will print something to the console window so that it will be useful. Console in the sense a debug console window. So we included the system diagnostics package. So this is for debug printing. Then our class contains 2 private member, number 1 and number 2. Then we have a constructor. Simple math is the class, and here is the constructor that takes 2 integer parameter and assigns the internal member, number 1 and number 2. Next, we have a static method add numbers that takes 2 number, adds the 2 number and prints the result in the console window. So here it is console means a debug window. So debug.writeLine, and we show the added result. This one is to test the static method, and here we have a member method, and if you see, the member method depends on the internal members, data member I mean. So number 1, number 2, that's why here we are not passing any parameter. Once you ask multiply, during the construction time itself we have the numbers populated, and here we are simply multiplying those 2 member, then printing the result, and at the same time we are returning the result. Here also we print the result in the debug output as well as we print the result. So we need to create a project called, so this will deliver a DLL output, and in that we will expose a class called simple math. And simple math, if you see, it exposes 2 private data member. That means n1, n2 you cannot access. That means these 2. I am not fully writing it as number 1, number 2. Let's say it's number n1, n2. Do not get confused with the parameter. Let me mark this internal member n1, n2. But all other stuff, if you see, they are public. Constructor is public, add number method is public, that's a static, multiply also public. So this is constructor, this one is a static method, member method. So publics are constructor is public, static method exposed as a public method, then the member method also exposed as a public. That means all this stuff is available for the external world. So through reflection, what we will do, we will load this DLL at runtime. We will look for the available public functionality. Then we will access the static method and member method. So we will access both through reflection. All right, now as part of the demo, we will go ahead and create the DLL project. Here we have Visual Studio. We will create a new project. So project type is Visual C++, and I am picking it as a class library and choosing D drive temp2 as the location, and naming this project as a delay load DLL. Solution name also I am giving the same, delay load DLL. Create directory for solution. So this will create a delay load DLL project. So we will rename this class as simple math. Click yes here. This will rename our class name simple math. So we will include the namespace for debug diagnostics. Then we will have two private member as part of our class. So this is just a sample. We declared two private member, number 1 and number 2. Next we will have a constructor, and if you see, the constructor takes two parameters n1, n2, and initializes the internal member number 1 and number 2. Then for demo purpose, we will create a static function add numbers, and this add numbers takes two integer parameter n1, n2, performs the addition, prints the content in the debug output window, then it also returns the result to the caller. Since it is a static method, it doesn't depend on the class instantiation. So you don't need to create object. You can directly use the class name simple math dot odd number. Like that you can make a call to this method, and it will help us to study how we can call this add numbers through reflection. Then we will have a member method also. That means to call this member multiply, first we have to construct the instance. The construction will initialize the internal data member number 1 and number 2. Then when you make a call to multiply, the internal member will get multiplied and the result will get printed in the output window, and the same is returned to the caller. That's all. Now we will rebuild the solution. So here you can see rebuild all succeeded, and this is the DLL output, and the DLL output name is delay load DLL. So let's see how reflection works, and And if you see here, delay load DLL is the namespace. So I am in class view right now, delay load DLL, and the simple math. Once I click, you can see add number, multiply, simple math, number 1, number 2, these two are private members, and all these 3 are public. You can also, so now here I'm in project, in the class view inside the solution. Now we will use a tool called ILD ASM. So IL disassembler. Let's run this as administrator. All right. Now we will rebuild this solution once. And in the output, you can see the DLL location. Let me copy this and choose file, open. Okay, I am already in that location. So I am loading this DLL through this disassembler. So if you see, this disassembler also works based on the reflection. And in the previous subseries, we used the example to retrieve the information about the types exposed by assembly. Here we loaded the assembly. The assembly is delay load DLL, and if you see, this tool exposes the project name. Then once I expand, we'll be seeing a simple math. That's the math function. So this is not a resizing here. So anyhow, if you need, you can select all and copy and paste this to the notepad and see the detail of the assembly. All right, this is simple math. Now let me expand this as simple math, and you can see number 1 private, number 2 private, and we have constructor as well as 2 member. One is a static. Here it shows the S letter shows the static. Multiply, that's the member method. All right, so now our DLL is ready. We will load this DLL and we can make a call to the methods exposed by this DLL. That's all here in this video. Thank you for watching. Bye.